portion of the meeting where I turn things over to Mr. Vice President, and he will introduce tonight's featured speaker.
Tonight we're going to hear a presentation from Jerry Dunifer. Jerry is a professor emeritus in the Physics and Astronomy Department at Wayne State University. He enjoys solar eclipses, visiting astronomical observatories around the world, as well as sailing, flying airplanes, and traveling to exotic locations such as the North and South Poles. Tonight his presentation is going to be a little closer to home, nearby states, I guess, east of us. I'll let him take it away from here and explain the rest to us.
Thank you, Ralph, and good evening, everyone. As was mentioned, one of my hobbies since I've retired about 10 years ago is to travel around the world visiting large and historic telescopes, among other places. Can everybody hear me? Yeah. Okay. And in the U.S., when I've done this, I usually go in a southwesterly direction, which takes me down towards California, Arizona, and states like that. So in California, one can see things like Mount Palomar telescope, the famous 200-inch telescope. There's a Jet Propulsion Lab, SETI headquarters, search for extraterrestrial intelligence. In Arizona, there are places like Kitt Peak Observatory, the Lowell Observatory, where Pluto was discovered. The Steward Observatory Mirror Lab, where they fabricate these giant mirrors, more than 8 meters in diameter, for the modern telescopes, and so forth. But this evening, I'll tell you about a trip we took in the opposite direction. So this was back in September of 2015. I think it is during the time that the gravitational wave was detected, which was September 14th, was it?
Right.
Okay, yes, I had no idea. But
You mean you didn't feel it?
I didn't know. It went by and I missed it. And on this trip, we visited a number of interesting places. The Allegheny Observatory. We took a little side trip to Falling Water, which is Frank Lloyd Wright House. Went to the Green Bank Radio Telescope, to the Smithsonian National Air and Space Museum, the U.S. Naval Observatory in Washington, and then we ended up at the Goddard Space Flight Center in Maryland. So on this trip, accompanying me was a friend of mine, Dr. Ismar Centora, who is a retired vascular surgeon who lives in Phoenix. And at the end of my talk, we'll get back to what is he holding here in his hands. And this is the automobile that we took. This is my 2011 Toyota Prius, which took us many hundreds of miles and got better than 50 miles per gallon economy. So let me start with the Allegheny Observatory towards the end of day one. So again, it's in Pittsburgh. It began as a private astronomy club, but a few years later it was donated to Western University of Pennsylvania, which later became the University of Pittsburgh, which still owns and controls the observatory. So they have 3 major telescopes there, 2 refractors, a 13-inch and a 30-inch. They have a 31-inch reflector. And research began there in 1867 under Professor Samuel Langley, who was the director at the time. And the research they did has to do with a lot of measurements of stellar positions. So they did stellar parallax, stellar proper motion, spectroscopy of binary stars, looked at solar spectra, photometry of variable stars, and so forth. So you can go there and have a tour yourself. The tours are free. They go for about 2 hours in the evening on Thursdays and Friday. You simply have to make a reservation in advance. So the observatory is located in Riverview Park, about 3 or 4 miles north of downtown Pittsburgh. Adjacent to the observatory is a sign telling you what it is. And this is the observatory building. There are two domes that you can see here. This is the front entryway. There's actually a third dome which is even bigger. So if you go off to the side, you can see this larger dome in the back where they have their large refracting telescope. So here we are, waiting to get in. You probably can't see it, but Allegheny Observatory here. And once inside, we were taken around on a little tour. We saw 3 telescopes. So this is the 13-inch refractor, and I see a little bit is missing here. It was purchased in 1861 and was used for many, many years. It's still in use today. Interesting story. 11 years after it was purchased, in 1872, the 13-inch lens was stolen. And it was held in ransom. So they took the lens up there and they demanded money in order to bring it back. But the director at the time, Samuel Langley, refused to pay a ransom, and eventually he was able to have a secret meeting with the thief and get it back. However, when it came back, there was a large scratch across one of the surfaces, and so they sent it to Alvin Clark in Massachusetts to have one surface refinished. And when it came back, they were all surprised that it was considerably better than it was before the burglary. And so, you can't see it here, but it's been named the Clark telescope, because the lens up here has been finished on the 2 surfaces by 2 different companies. So, this is the 30-inch refractor. This is the 3rd largest refractor in the United States, and been used for many years doing things like stellar parallax, proper motion. Today it's even used to look for extrasolar planets. And over the years they took something like 110,000 photographic images on glass plates, which they have in a giant library. They have one of the world's largest collection of astrophotography on glass plates at this observatory. And this is the 3rd telescope, the 31-inch Keeler reflector, which was obtained back in 1906. And they do a variety of studies, stellar spectra, spectroscopic binaries, even quasars. So this is the 13-inch refractor. We were in the dome and they were going to open it so we could look through it and see a few things. But the clouds rolled in about the time they were going to do that, and that got canceled. We got taken into the dome, which has the 30-inch refractor. So this was our tour guide right here. And interesting, the wooden floor he's standing on is an elevator. So it rises and lowers according to where the end of the telescope is to make it easy to look through. So I've been through to the 3 largest refractors in this country, and they all have the same thing. A wooden floor that goes up and down, so you can get easily to the eyepiece. Okay, day 2. Started out early and went to Falling Water. This was a weekend home designed by Frank Lloyd Wright back in 1935. It was built for the owner of one of the department stores in Pittsburgh. It's built partly over a waterfall, about 40 miles from Pittsburgh, and it's listed as a National Historic Landmark and of interest. The Smithsonian Institute has put out a list called their Life List, which is 28 places which they suggest you should see before you die. The most spectacular places on Earth, like the Taj Mahal, like the Grand Canyon. And lo and behold, Falling Water is one of these 28 places. So we thought we had to swing by and see it. So it's down in southwestern Pennsylvania, approximately here. And this is what it looks like. And I'll go through a few quick pictures. And in the autumn, back of it. The materials which are used are primarily just local materials, the rocks which they got right there, and they incorporated in the construction of the house. And a few pictures on the inside.
Is it people live there or is it a museum?
It's visited by tens of thousands of people
Okay, so it's
every
like-
year. So the people streaming in and out. Nobody lives there. It's enormously popular.
Question,
Yes.
how loud is the waterfall when you're inside?
Well, no, you can't really hear it inside. And it depends on the season because sometimes there's quite a bit of water going over. There was just a moderate amount while we were there. But we didn't hear it on the inside. Okay, at the end of the day, we ended up in West Virginia going to the Green Bank Radio Telescope. So this is the world's largest fully steerable telescope. It's operated by the National Radio Astronomy Observatory, NRAL, in Green Bank, West Virginia, latitude 38 degrees north, which allows it to see about 85% of the celestial sphere. So it can see most of what is up in the sky. It's in the center of the U.S. National Radio Quiet Zone, which is quite a large area, about 13,000 square miles, in which radio transmissions are severely restricted. It's adjacent to it is the Green Bank Science Center, which you can get in for free. You can also, for $6, take a bus tour, diesel bus, because they don't want any radio interference generated by spark plugs, which takes you right down to the telescope. In fact, several of the telescopes that they have there. So, some specifications. 17 million pounds is the weight. The area, the primary, 100 meters by 110 meters, almost 500 feet tall. The collecting area of the primary, 9,000 square meters, or 2.3 acres, if you like those units, or 2 football fields. There are 2,004 individual aluminum plates, which have been machined to a precision of 3/1000th of an inch, and they are controlled by 2,200 actuators, small electric motors which move the plates around to maintain the proper shape, no matter how the antenna is oriented. It looks at radio wavelengths from 3 meters down to 2.6 millimeters, or like frequency from 100 megahertz to 116 gigahertz. And the pointing accuracy, 1 second of arc.
Hey, sir.
Yes.
That Green Banks, that's where that Shuttle telescope or that antenna that was used to discover the background,
No.
the CMB? Is that,
No.
Oh, is that a different
No,
place?
that's in New Jersey.
Oh, that's,
Yeah. No, that's not this one.
okay.
Okay, so this is the Science Center, which is adjacent to the telescope. And just outside the Science Center is this radio telescope, which turns out to be very famous. This is the Reber Radio Telescope. I'm not 100% sure on the pronunciation, Reber or Reber. I think it's Reber, if anybody knows. This was the first parabolic radio telescope built by Goddard Reber in his backyard in one of the suburbs of Chicago back in 1937. And at the time he built it, he was the only radio astronomer in the world. 6 years earlier, Carl Jansky had built a dipole antenna and had discovered radio waves coming from the Milky Way galaxy. Reber telescope is made up of sheet metal, 31 feet in diameter, and it sort of served as a prototype for many radio telescopes which followed. It was eventually sold to the National Bureau of Standards and later transferred back to NRAO, and it moved around a bit, going to Virginia, Boulder, Colorado, and eventually to Green Bank, West Virginia, where it is today. So here's the telescope again. And this is Goddard Reber, 1937, about the time he built the telescope. So this is the Science Center, Green Bank Science Center. And when you go inside, there are quite a few exhibits. Most of them have to do with radio waves or just waves in general. also a display on the telescope outside the building. So this is a model of the big telescope, which is there now. And I don't know if you could read it or not, but it talks right behind it. It says disaster, loss, and progress. So what is the disaster? Well, prior to this telescope, there was an earlier telescope, about 300 feet in diameter, 90 meters in diameter. This is what it looked like. And this is what it looked like on the last day it was in use. And the following day, it looked like that.
Oh, geez.
There was a massive mechanical failure, and the thing collapsed, and they were out of business for quite a number of years.
And what year was that?
I will come up with that in a second. Okay, back inside the Science Center, another model of the current one. There's a cafe there where you can get good food like hot dogs and hamburgers and things like that. And you can sit here in a very nice area with picture windows, eating your meal and looking out at the big radio telescope out through the window. And there's an observation deck nearby. And from the observation deck, telescope looks like this. And with maximum zoom on my camera, it looks like that. Okay, a few pictures. I don't know if you can read it, but this is, it's got a name now. It's the Robert Byrd telescope, named after a senator of West Virginia who sort of pushed funding for the telescope through Congress. So it's because of him that the telescope is there, and it's named after him. So another view of the telescope. This is the primary reflector here. It doesn't look at signals coming in on axis, or rather signals coming in off axis, which are reflected up to a secondary and then down to the receiving antenna, which are here. And to give you a feeling for how large this is, you probably can't see it, but there's a person standing here, and magnified the person looks like that. Okay, a few more views. This is a view from the air, view from the ground, another aerial view, another view from the ground. So here, these are people down here. You can see how large they are compared. Again, this antenna is about 500 feet in height. And one last aerial view showing you the big antenna and also a few other antennas which are in the area. So the bus tour takes you around to most of these antennas, and you get a little description about why they're there, what they're doing, and so forth. A little more information on the Green Bank Radio Telescope. It is the world's largest moving land object. It was completed in the year 2000. Annual operating budget's about $10 million. Again, you can see about 85% of the celestial sphere. Made a number of discoveries, but of interest is there is a project called Project Breakthrough Listen, which starts in early 2016, which is about now. And this is a $100 million project which will take place over 10 years to search for extraterrestrial intelligent life, SETI. It's sponsored by a Russian tycoon, Yuri Milner, and this telescope will use about 20% of its annual observing time looking for SETI signals out there in space. A little bit about the previous telescope. It was 90 meters in diameter, erected in 1962, collapsed. Here we go, 9:43 p.m. Eastern Standard Time, Tuesday, November 15, 1988. So that's the day it came down. It was due to the loss of a gusset plate. These are large steel plates that hold various beams together, where they come and meet at a particular point. Day 3 found us in Washington, D.C. We went to the Smithsonian National Air and Space Museum down in the mall. This is the largest of Smithsonian's several museums. It has more than 8 million visitors per year. It is the most visited museum in the country. They have a collection of tens of thousands of objects, which range from aircraft to rockets to space probes, to other things, historical artifacts. Large number of galleries, one devoted to the history of astronomy. So this is the entryway. And if you go in the main doors, you find yourself looking at some interesting things. Here's the Spirit of St. Louis. Here's Spaceship One. This is the command module for Apollo 11. So again, this is the Apollo 11 command module. This took Neil Armstrong, Buzz Aldrin, and Michael Collins to the moon for man's first landing on the surface of the moon. Spaceship One, or Spaceship One. This won a $10 million prize for being the first spaceship privately funded to fly a person from a mother ship at about 49,000 feet. It was called White Knight. It was dropped, rocket engines went on, and it went up to an altitude of 100 kilometers, 62 miles above the surface of the Earth. So it is hoped one day that Virgin Galactic will be sending private people up to the edge of space, 100 kilometers up, in rocket planes like this. I haven't checked recently, but the last time I looked, I think a ticket is about $250,000. I don't know if it's gone up or not. Maybe it's come down with the accident that they had.
I don't think they're going anywhere anytime soon.
Stephen Hawking, I know, has a ticket and is supposed to be either on the first or among the first people to go up. Have you heard anything about any progress or lack thereof?
After the disaster, I haven't heard of them
It's
flying
been real
since then.
quiet.
Yeah.
It's been real quiet.
Real quiet, okay. Spirit of St. Louis, first plane to fly across the Atlantic. Charles Lindbergh piloting the plane back in 1927. They flew from Long Island, New York to Paris, France, 3,600 miles, 33 and a half hours. And that's the plane. This is Apollo-Soyuz. These two craft met in space. So this is the Apollo command module and service module and the Soyuz spacecraft. And in between is the docking module where they came together and docked back in 1975. And another view of Apollo-Soyuz. This is the Apollo lunar landing module. This has been made up to look like the one which landed on the moon for the first time, the Eagle, Apollo 11. So this is a two-stage rocket which is designed to take two astronauts from lunar orbit down to the lunar surface and back up to lunar orbit again. And then finally, we have this craft. This was the North American X-15. This was a rocket-powered hypersonic aircraft. It was flown in the 1960s. It set a number of altitude and speed records. It currently holds the speed record for the fastest speed for a man-powered aircraft. That speed is 4,520 miles per hour, Mach 6.7. It turns out to be about 25% of the orbital speed of a near-Earth satellite. So this rocket plane could really go. And it achieved altitudes in excess of 100 kilometers above the surface. The following day, now we're up to day 4, we went to the other National Air and Space Museum, the UdvarHazy Center, which is located about 20 miles away from the first one out in Virginia. It opened in 2003. They have 2 large hangars, and they have a number of interesting artifacts, including they have a Lockheed SR-71 Blackbird, a supersonic transport Concorde. They got the Boeing B-29 and Enola Gay, which dropped the atomic bomb in Hiroshima. They have the Space Shuttle Discovery. So they got an observation tower, which gives you a great view of the Washington Dulles International Airport, planes coming and going. And it's open daily free admission, but they sock it to you for parking. You've got to pay $15 to park a car there. Okay, so from the parking lot, this is the observation deck, and the main entrance is right over there. At the main entrance, looking back, there's a rather spectacular sculpture, which is right there, all metal and gleaming and very reflective. So going in the door, and I stopped for just a minute to take a picture of myself. Look carefully in the reflection here, that is me taking a picture of myself taking a picture. And once you go inside, there it is, Space Shuttle Discovery. I could use a little cleaning, so that's the rear where the nozzles are. And it's looking at the right wing. Well, pay attention, there's an American flag here and the name Discovery. And I'll show that to you again in another couple slides. So a little bit about the Space Shuttle. First flight was back in August of '84, and the last flight was February 2011. It had 39 missions. It was sent into space 39 times. And during that time, there were 252 different crew members, which went up with the shuttle. It was in space for a total of 366 total days, just in excess of 1 year. In space, it traveled 148 million miles. More space flights than any other spacecraft. It deployed 31 satellites, including the Hubble Space Telescope. Had 13 dockings with the International Space Station. And John Glenn, the oldest person to go into space at the age of 77, still time for me, flew up in this Space Shuttle Discovery in 1998. So this is on one of its launches. I don't know if you can see it or not, but there's that American flag and Discovery on the right wing. So this is the external fuel tank, and on either side of the two solid fuel rocket boosters. And this is one very bad plane. This is just as bad as they come. Black as coal. This is the Lockheed SR-71 Blackbird. This is a long-range, high-speed, high-altitude spy plane developed at Lockheed Skunk Works Division. It was flown for 33 years, from 1966 to 1999. It could maintain sustained flight at 85,000 feet up at 2,200 miles per hour, Mach 3.3. Has a titanium skin, and parts of it reach a surface temperature of 600 degrees Fahrenheit during the flight due to air friction. The one what we just saw, the one on display, was flown in from Los Angeles. It flew from LA to Washington, D.C. in 64 minutes, 20 seconds. Across the country without refueling, reached a top speed of 2,242 miles per hour, along the way setting a new speed record. It's been used for 33 years to do espionage. It has had missiles shot at it, but they couldn't catch up. It was just too high and too fast. A couple pictures in flight. So this is the Blackbird here, this one. Not the closer plane. The Enola Gay, which is a B-29 Super Fortress bomber, which dropped the bomb on Hiroshima. That plane is there. And they also have the Supersonic Transport Concorde. Beautiful plane. Oops. A little about the Concorde. It was just above Mach 2, 1,350 miles an hour. Began flying in January of '76 and ended in October of 2003. Flew for 27 years. Would typically take about 100 passengers. For example, flying from JFK Airport in New York to Heathrow Airport in London was just a little bit under 3 hours for the flight. Not flying today. There were a number of problems. Very expensive to operate. high rate of fuel consumption and a small number of passengers. Very noisy at takeoff. There was the sonic boom. Because of the sonic boom, it wasn't allowed to fly across this country supersonically. And there were at the time concerns about the effect it might have on the ozone layer in the stratosphere, because it did fly in the stratosphere. Here's a picture in flight, beautiful plane. I spent a year on sabbatical in London, and we lived near Kew Gardens, and occasionally when we'd go to Kew Gardens, which is not that far from Heathrow Airport, we would see the plane coming in, and seeing it in the sky flying, it's just a beautiful sight. And a couple more pictures inside. They have a lot of planes. And then coming back out, that sculpture and was just picking up the sun at that point, so it looked even more spectacular. And I don't see it here, but there's also a plane flying out of Dulles Airport, sort of right up in there. Okay, so that's the first 2/3 of my talk. So let me see if I can do this.
Got it?
Oh yeah, go ahead. Okay, thank you. So, part 2, we visit the U.S. Naval Observatory in Washington, D.C., and the Goddard Space Flight Center in Maryland. So a little bit about the Naval Observatory. It's one of the oldest science agencies in the U.S. It was created way back in 1825 by President John Quincy Adams. Primary mission is to produce positioning, navigation, and timing data for the Navy and the Department of Defense. They also have a James Gillis Library inside, which is the largest astronomy library in the country, and it has the largest astrophysical periodical collection in the world. They've also got a number of quite famous and rare books on astronomy and physics from the past 1,000 years. I should also mention the moons of Mars. Phobos and Deimos were discovered here back in 1877 by Asaph Hall using a 26-inch refractor. And since 1974, the official residence for the Vice President, now Joe Biden, is on the grounds of the Naval Observatory. If you want to send him a letter, the address is #1 Observatory Circle. So this is a little grainy view from an aerial view. The main building, you can see a number of domes here and there scattered around. But the main building is this building, and the Vice President's residence is this house right here. Looking in the opposite direction, this again is the main building, and this is the Vice President's home. So this is the main building, seen from the ground. I took several of these pics. Yes?
Did you find out why they located the vice presidential residence near the observatory or vice versa?
I don't know the history as to why that was chosen. It hasn't always been that way. It's been the last couple decades or so. But no, I don't know why. It's close. It's
So
close.
we can keep an eye on things.
So you can keep an, thank you, keep an eye on things. I like that.
Unobstructed by light pollution.
Okay, now another view of the main building. On the left side, there's a dome up here, to which we were taken in our tour and spent about an hour up there looking through the telescope. I think we were looking at Jupiter, a couple different things. And there's also a ball that they used to drop at high noon every day, so people could set their watches. So again, the ball and the observation dome was taken in the spring. The tour that we went on was the first one in about 3 or 4 months. And it was scheduled to start, I think about 8:30 in the evening. It was dark. I wasn't able to get any pictures myself. I had to take these off the internet. But this is the telescope that we looked through while we were up in that dome. And a couple more pictures of the Vice President's home. This one, and this one here, aerial view. And again, the main building is over here. So this is the center part of the library. And this was one of our tour guides. We had about a 2.5-hour tour. We had 3 different guides that would take us around building to building. So this was the guide we had in the main building. I don't remember his name. This is an instrument that was used a lot in previous years. This is a 6-inch transit circle telescope, which is used to look at celestial objects passing across the meridian. So the meridian is this imaginary line which starts in the south, goes to the zenith, and then goes down to the horizon in the north. And this was used to look at objects crossing the meridian. They would measure the exact time the object crossed the meridian, and that would give them the right ascension of the object. They would measure the angle above the horizon on the meridian when it crossed, and that would give them the declination. So they could get the coordinates of celestial objects like the stars, the moon, the sun, the planets, and so forth.
Question?
Yes?
That would give them the time relative to what?
Well, what do you mean
How
relative?
do they know what the correct time was?
The U.S. Naval Observatory is the time.
Exactly.
No, Greenwich
Yeah.
is the correct time.
This is local time. This
Yes,
will give you
but-
exact local time.
Well, yes. Well, they use their master clocks, which I'm sure are properly synchronized relative to Greenwich Mean Time or any other applicable time.
This was designed to give you your local time.
But this was before
Before
Well,
radio,
yeah.
so how could they synchronize with Greenwich?
They started using it in 1899, and it was used up until 1995.
I think,
So-
I mean, you would use the stars, you would use the stars that you know the coordinates for to.
Yeah, to get relative
Yeah,
time.
meridian circles, you'll find those around the country in different observatories. We have one in Ann Arbor, actually, at the
Mhm.
Detroit Observatory, and it was used to set local time, mostly used for the rail,
Mhm.
for trains.
That's what was done originally. Going back to the Allegheny Observatory, they also had a small transit telescope, and so they were looking at when various celestial stars and so forth would pass over to get the time, and then they would sell the time to people who needed to know the time accurately, like the railroads.
I mean, here's the thing. You build this observatory,
Right.
right?
Yes,
You can see when a given star comes over exactly.
you can, right.
But
And you-
unless you know your exact longitude, I don't see how that gives you the time.
Well, how do you know they don't know their exact longitude?
Well, how would they measure their exact longitude?
Well, I don't know the details,
I think Jupiter
but
transits
they were the
was,
source of time. And so they
Yeah.
knew when the objects passed according to their time.
Standard time and, I
But
mean,
you build up a catalog, as far as I know, so that you know what.
Jonathan may have the
That
answer.
sounds like, yeah.
Jupiter
that's-
transits.
Yeah, we should assign that as a homework project to you. You could give us a talk sometime on the techniques they use.
Jerry?
What day do you want for that?
good job.
I'll be the teacher.
I did used to teach, and I know how to handle troublesome students.
Yeah, he only has
That's right.
Question if it gets-
Okay, so sometime in the
Yes.
future, Dale Parton will be giving us a talk on procedures at the observatory to determine exact latitude and longitude. Anyway, this instrument was used for almost a century, and during that time they determined the coordinates of about 1 million stars, and they were able to do it to an accuracy of about 5/100ths of 1 arc second. So it's a high precision instrument, but the exact procedure you will enlighten us on. Okay, time. The time at the U.S. Naval Observatory. They have a clock there, and I put it in parentheses because it's not just a clock. It's actually determined by an average of an ensemble of 50 cesium beam atomic clocks and 12 hydrogen maser atomic clocks, which they have situated in environmental chambers which maintain a constant temperature and humidity. There's also an alternative master clock, which is out at the Shriver Air Force Base near Colorado Springs. And that uses 12 cesium beam clocks and 3 hydrogen maser clocks. So for a number to look at, the cesium beam atomic clocks are stable over fairly long periods of time to 8 parts in 10 to the 14th. That's 1 followed by 14 zeros. They also operate 4 rubidium atomic fountain clocks, which are stable to 7 parts in 10 to the 16th. I don't think the rubidium fountain clocks are used in the master clock. They may be experimental clocks, and they're developing more advanced techniques for more precise timekeeping.
There is a question here.
Yes,
If one of the clocks is different than the other clock, which clock do they throw away?
I guess it depends how different it is. No, well, it's a whole bunch of
Well, it's
clocks.
an average of
Yeah,
62
yeah.
clocks.
Right. If one is clearly way off the average of the others, I'm sure it goes out and gets replaced.
You got some rogue students here tonight.
Yeah,
Gary.
we'll come up with a project for 10 versions. So anyway, the master clock also is used to give time to the GPS satellites. So if you're walking down the street by the entrance, you can look at the sign and you can set your watch accurate to a microsecond or something like that. The cesium beam atomic clocks are quite small and compact today, so there's several of them here in relay racks, which you see. And this larger structure is a hydrogen beam atomic clock. And these are some of the environmental chambers in which they put the cesium beam clock. You'll hold 4 of them, and you can see 4 of them there. Give them a constant environment so that they remain very precise. And this is a picture of U.S. Naval Observatory alternate master clock, which is out in Colorado. The Naval Observatory does something else. They determine the Earth orientation parameters. So they use very long baseline interferometry of radio waves to make high precision determination of the position of distant quasars. And that gives them a fixed reference frame. And they use that reference frame to determine how the Earth is oriented. So they can determine, for example, the exact orientation and position of the Earth's axis of rotation and the Earth's current rate of rotation. And they determine this on a daily basis because the Earth does not rotate in a constant and fixed way. There's small fluctuations, and they monitor those. Okay, day 5. This gets us to the Goddard Space Flight Center. And while there, we were able to hear a seminar that was given by 2 astronauts who just a couple weeks earlier had come down from 200 days on the International Space Station. So they gave a very interesting seminar with lots of spectacular pictures and videos. And we also got a tour of the James Webb Space Telescope, which is now under construction at that location. So Goddard is the first and oldest space research center. was named after Dr. Robert Goddard, who was an American pioneer in developing liquid fuel rockets. The center was formed back in May of 1959 when I was graduating from high school. It's located in Greenbelt, Maryland, just about 7 miles from downtown Washington, D.C. They employ about 10,000 people. Their efforts are focused on designing unmanned satellites and spacecraft for scientific research purposes. And they have developed scientific instruments which have been sent to every planet in the solar system. And adjacent, there is a visitor center, which not only has free admission, they have free parking. So this is the visitor center, which is here. In the background, you can see a Delta rocket. And on the right, by this NASA sign, is a gift shop. And that's where I bought my t-shirt. My asked for a t-shirt, Goddard Space Flight Center, right there. So this is the Delta rocket. And inside they have lots of exhibits. We spent about 3 hours there, so there was a lot to see and do. The model of the Hubble Space Telescope. They had a darkened room with a large screen called a solarium, on which they showed a number of images that had been taken by satellites like SOHO of things happening on the surface of the sun, along with sounds, which are actually produced from the vibrations of the sun itself. So this is a model of the James Webb Space Telescope, and I'll come back to that in a minute. So we had a private tour. You can go to the visitor center with no problem. That's open to the public, but getting in the main campus is not so easy, and so it took about 3 months to make arrangements to get in. But eventually Maggie Mazzetti agreed to do it for us, and she was very generous with her time. She spent about 3 hours with us, maybe 3.5 hours, taking us around, showing us lots of things. So first of all, we went to a lecture by the 2 astronauts, Terry Virts and Samantha Cristoforetti. Samantha is Italian. She's a member of the European Space Agency, and Terry Virts is American. We saw a large vacuum chamber in which they test spacecraft and various components. It can be heated or cooled to either plus or minus 200 degrees Celsius. We also saw a great big high-capacity centrifuge, which can generate up to 30 Gs on a load as large as 2.5 tons. They have the world's largest clean room with 1.3 million cubic feet of volume, and it's in this clean room that they're now building the James Webb Space Telescope. So this is an aerial view looking down on the campus. Off in the center you can see that Delta rocket. So this is the visitor center, which is right over here. Probably the biggest building there is this building. This is building number 29. And it includes the centrifuge. This is the centrifuge here. It includes a giant clean room and a number of other facilities. So most of the time we were there, we spent in that building. First of all, we went to the seminar by the 2 astronauts. So here they are. And they signed, they autographed their photos for us after the talk. So here I am getting my photograph. And this is my friend Esmar getting his. So here we are, Terry Virts, Jerry Ostro, I think that's, or Ostra, I think that's Latin for to the stars.
Mm-hmm.
And to Jerry, all the best from Samantha. So here we are outside of building 29. And in the background here, this is a large vacuum chamber. We're testing spacecraft. Here's a giant centrifuge. And And this is Ismar and myself with the giant centrifuge. And here we are standing outside the giant clean room. So Ismar and myself. And in the background, this is the James Webb Space Telescope you see right here. And there are probably about 12 to 15 technicians inside that were in the process of assembling it while we were there. So this telescope is going to be the successor to the Hubble Space Telescope and also the Spitzer Space Telescope, which is an infrared telescope. It will make primarily infrared observations extending just a little bit into the visible. So a wavelength in the orange of 600 nanometers and then increasing wavelength down to 28 microns. So the goals of this, once it's in orbit and launched, is to observe the birth of the earliest stars and galaxies following the Big Bang. To be able to look back far enough in the history of the universe to witness the formation of the first stars and galaxies. It also will be used to study current star and planet formation, looking into these dusty nebula in which visible light cannot go. They hope for getting direct imaging of exoplanets and studying the evolution of galaxies throughout the history of the universe. So another picture looking down into the clean room. And here are some of these technicians at work. Notice they're all dressed up in these white suits. So they don't get any hair or skin cells or anything like that on any of the delicate components. So here are 4 of them up close. So it's like they're dressed up for surgery pretty much. And I think the level of cleanliness is about the same, if not more so. These are called buddy suits, which they are wearing. So another view. So what you're seeing here is primarily the framework. They had not yet attached any of the mirrors. And so this is the framework. You see there's a lot of black beams which make up the framework. And these are not steel or aluminum beams. They are what Ismar is holding. So on the left here is one of the black beams of the type that you saw. These are high-tech, very lightweight, very strong carbon fiber running throughout to increase the strength, compared to what if you were using aluminum to build it. And these basically the same length, same strength, but the high-tech material 10 times lighter in weight.
That carbon fiber?
Carbon fibers run through it.
It's unobtainium.
Unobtainium. There you go. So here's a model of the spacecraft once it's finished. So this is the reflecting antenna, and which focuses incoming radiation on detectors up here. It has to be shielded from the sun because it operates at very low temperature. And so the bottom of this is a sun shield. The bottom is facing the sun. And the telescope itself is in the shade of the shield, much cooler. So this shows you putting on the first mirror. This is, here they've got 2 mirrors, 1 and 2, which have been installed. And here's a very current picture. You can go online to their web camera and you can see for yourself the construction day by day of how things are progressing. Just go to JWST, James Webb Space Telescope, nasa.gov/webcam.html, and you'll see this. You see a picture, it's updated once a minute. So see, I took this yesterday afternoon at 4:40, and there were 3 technicians working over here, a couple technicians down here. They weren't nearly as busy, they haven't been the last few days compared to what they were when we were there. Another one, this was taken, this morning at 10:30. And again, there's some technicians here. And let's see, there are 2 more down in here somewhere.
Jerry, is that going to be sent up and then somewhat disassemble and assemble it when they get there?
It's gonna be, it's gonna, once it's all assembled on ground, it's gonna be folded
Whole
up.
thing up, that's good.
Yeah, the whole thing folds up in a nice compact package. And then once launched, hopefully it's gonna unfold correctly.
Yeah, hopefully.
Hopefully, yeah.
going
There's
to
a
the
lot
yellow
riding on it. So this is a full-scale model way back in the year 2005 at Goddard. That's how large it will be. A little bit about it. So it's got 12 hexagonal mirrors made from beryllium, which are gold-plated. When they're assembled, you end up with a mirror 6.5 meters in diameter. And for comparison purposes, Hubble's 2.4 meters in diameter. So the collecting area is going to be about 7 times that of the Hubble telescope. The sun shield is made up of 5 layers of a polymer film, which is coated with aluminum on one side, silicon on the other. So the side which is facing the sun, the hot side, will get it to about 185 degrees Fahrenheit. The other side, in the shade, will drop to about minus 388 Fahrenheit, or 40 kelvins, 40 degrees above absolute zero. They also have a helium refrigerator on board, which will cool some of the instruments down to 7 Kelvin, 7 degrees above absolute zero. Prime contractor is Northrop Grumman in California. Total cost today, $8 billion. This is way over budget. It is way behind schedule. It was supposed to be in orbit years ago, but there have been all kinds of delays and cost overruns. At one point, Congress was on the verge of cutting all the funding and canceling it. But eventually they worked out a compromise, and so far it's still go. 17 participating countries, with Europe and Canada having big roles. So in space it will look like this. Question, yes?
So when this goes online, what will be the status of Hubble at that point?
Who knows what Hubble is? I'm sure they'll use Hubble as long as it's working. Sooner or later, the gyroscopes are going to die on Hubble. It won't be able to point, and it'll have to be decommissioned. So,
When is the launch?
when is it going to be launched?
2018.
October 2018. Okay, so let's see. This was the cold side. This is the hot side, the side which is facing the sun. And this is back in California, where the manufacturer is spreading out the various layers of the solar shield. This is one of the hexagonal mirrors, which has just been gold-plated, and the technician's inspecting it. So it's the size of one mirror compared to a person. These are cluster mirrors which are being tested at cryogenic temperatures. So this is a comparison of the Hubble, which is about 2.4 meters in diameter, versus the James Webb Telescope once it's completed. And this just shows you a bunch of mirror sizes for all kinds of telescopes, both on the ground and in space. So this is a Hubble Space Telescope, and this is James Webb. And there's a whole bunch here, and then some of the bigger ones on the ground, like the Kent is up here. So I've been to most of these, not all of them, but most of them. Still have a few more to go. Okay, so the launch of the James Webb Space Telescope, scheduled, as we said, October 2018. The launch vehicle will be the Ariane 5 rocket, provided by the European Space Agency. 2-stage rocket with 2 solid fuel boosters. Very good track record. 60 successful launches, only 2 failures. Launch site is going to be French Guiana down near the equator, which will give it a little extra velocity boost on launch. It's going to be situated, will not go in orbit around the Earth. It's going to be placed out at the Earth-Sun L2 Lagrange point, which is about 1 million miles further out from the Sun. It won't just be sitting there, it'll be traveling in an orbit about that point, called a halo orbit, which is set up so that the shadows of the Earth and Moon don't fall on it. A very large orbit. It has a radius of about 800,000 kilometers. The orbital period is about 6 months. So this is the Ariane 5 rocket at launch. This is the location of the L2 Lagrange point. Sun here. This is the orbit of the Earth. Earth here, orbit of the Moon. And about 1 million miles out is L2. And this space telescope will be going in an orbit about L2 like so.
Jerry, this is virtually unserviceable at that
It is
distance.
completely
We have no way of servicing it at the present time.
Unlike
There's no plans.
Unlike Hubble.
Unlike the Hubble, that's right, yeah. It's going to be far away and no way of getting people up there to service it. I just mentioned that the L1 Lagrange point is about here, 1 million miles closer to the sun, and satellites like SOHO are situated there. Looking. So, day 6 we drive home. So green belt coming back here to Michigan, 550 miles, 8.7 hours of driving time. My mileage in my Prius, 56.9 miles per gallon. Okay, and that's the end of my talk. Thank you very much.
You did all this in 5 days?
6 days driving back. Yeah, right. 5 days with everything else.
I have time for a couple of questions.
We were busy. We didn't have a lot of spare time. Yeah, question.
I have a joke question, so I'll pass.
I don't know whether you've heard this, but plans are already underway for a successor to the James Webb. It'd be like 12 meters.
12-meter diameter. Okay.
That's desired to increase light gathering and resolution for looking for imaging exoplanets, looking for
Yeah.
atmospheres.
Well, they won't be able to image exoplanets with this one. They should be able to pick them up on individual pixels.
Yeah.
They should be able to do spectroscopic analysis of those signals,
Image
get
is
information on the
wrong word.
atmosphere. Yeah.
Of all these observatories that you visited, do you have a favorite, or one that really stands out?
Oh, God, do I have a favorite?
Yeah.
I like the ones down in Chile, we saw, because we went down and saw 3 and they're quite spectacular. Probably the one in the Atacama Desert, a very large telescope, which is actually 4 telescopes which are interconnected and function together. It looks like we were on Mars when we were there. The Atacama Desert is so dry, there are places where it has not rained in over a century. And it looks like Mars, soiled red, and it looks unearthly. Yeah, that's probably my favorite place. Most exotic. I don't know, in the back there.
Jerry, did you eat in banana in Chile?
Did I do what in Chile?
I ate in bananas.
Did I have bananas?
Empanadas. Empanadas.
Empanadas.
No.
No.
No, I had pisco sours. Pretty good, actually. Yeah.
So how, is the observation platform as close as you can get to Green Bank? Like, have you ever been to Jodrell Bank in?
I have not been to Jodrell Bank, it's on my list. It's as close,
Manchester.
it's as close as you can get unless you pay $6 and get on the bus tour.
Okay.
Oh.
Then they drive you right up to it.
Oh, okay.
Okay.
So, I mean, you're standing there and you're looking up at this angle. to the
Okay,
top.
that's good, because Jodrell Bank you could get 100 feet away.
You could
Yeah,
walk right
yeah,
up.
yeah, we were right up there by the gate,
Okay.
right beside it.
2 more questions.
This Green Bank telescope, in 2016, the SETI project is going to get 20% of their time.
Right.
Does that improve the detection capabilities of SETI relative to what they've done in the past?
It's going to end up devoting a lot more time than they have done in the past. I don't know that they've used that particular telescope for that purpose previously. You know, they've used a number of telescopes.
I'm just wondering if you look at the
Bits and
basic
pieces, but-
capabilities of the telescope compared to what they've used before, is it better or not?
Well, previously,
I think I'm going to get a homework assignment.
Yeah. Let's have Bill's question, and then we really do.
Actually,
And Jerry had one as well.
I think SETI started out at that observatory, not with, probably with that antenna, but an earlier one. Frank Drake. And,
yeah. What was it? I'm not sure about that. Could have been.
Yeah, I think.
I know Frank Drake did a lot at Arecibo. with a much bigger telescope.
Yeah, also there later, I think, but he started there.
That may be the case, I'm not sure.
Phil had a question as well. What-
Jerry, the first one you were at, I think was Allegheny.
Allegheny, yeah.
You had a chance to look through the 30-inch refractor?
No, we did not, no, we didn't look through anything because it turned out to be cloudy.
Oh, it's pretty easy.
They were going to let us look through the 13 inch.
Okay. I was gonna ask you what you looked at.